Hey everybody, so today we are going to be looking at area of composite figures. Okay, so a composite figure is a figure that can be sectioned or separated into regions that are all basic plane figures or our basic shapes. Okay, these are plain flat shapes. So some sort of combination of triangle, rectangle, parallelogram, trapezoid, circle, the things that we've already been finding the area of. Okay, so imagine like the floor plan of your house, right? Your house is not a perfect rectangle or a perfect square. It has, a smaller rectangle connected to a bigger rectangle, connected to maybe a trapezoidal, we got this cool front window or something like that kind of sticks out of the house, all kinds of things. So any shapes that are combinations of these things are called composite figures. Composite, like a compound word, right? Composite is a bunch of things that are kind of put together. Okay, so to find the area of those composite figures, we are going to divide up the regions. So we're going to separate those. One word that you are going to see later is decompose. Okay, so if you see that word, decompose just means to divide it or break it up into sections, right? When food decomposes, it breaks up and goes back into the soil or whatever. That's my science lesson for the day. We'll pretend that was right. So we're going to divide or decompose up those regions, and then we're going to find the area of each one. And we are just going to add them all together. So we're going to take the sum of all of those areas, or we're going to add, right? So to find the area of composite figures, divide up all the regions, figure out what shapes we have, find the area of each one of those shapes, and we're just going to add them all together. Okay? So today we are going to look at a couple examples with these composite figures, and then next time we're going to look at shaded regions, so where the two shapes are like inside each other. So what we're going to see today is we're going to see shapes that are like side by side. Okay, so question number one is this a shape that we can find the area of? Please say no. Okay, so this is a composite figure, and we're going to separate this into smaller sections. So do you see a shape that we could divide in here? Okay, break this up, maybe like right across here. If I drew a line right here, do you see how I would have a rectangle up here at the top? And then what shape would this be down here? This would be a trapezoid. Okay, so I'm going to find the area of this rectangle on top. I'm going to find the area of this trapezoid on the bottom, and then we're going to find the sum of them, just add them together to find our total area of this whole inside space. Okay, so I'm going to come over here and I'm going to write area of rectangle, and I'm going to go to my formula chart, which I have in my head. You might need to have on your paper, okay, or beside you. Area of a rectangle is base times height. So on any shape, remember that the base and the height have to make that right angle to each other. That's really the most important thing. We're looking for the right angle between the base and the height. Okay, so if I were to color in just this rectangle right here, and I were to trace around the outside of that rectangle, what would its dimensions be? What are its side lengths of this rectangle? I got a 12 right here. And do I know how long this side is? This side is 23. So I'm going to have a base of 12 and a height of 23. 12 times 23, I'm going to grab my calculator. 12 times 23 makes 276. And those were centimeters, so that's going to be centimeters squared. Okay, so that's part of my answer. Okay, I'm going to maybe put a circle around that. Okay, that's the area of the rectangle. We already found that. So then we're going to do the area of the trapezoid. Can I fit it in over here? Area of a trapezoid is 1/2 B1 plus B2 times H. Sure, it'll fit. All right, 1/2 base 1 plus base 2 times the height. Okay, so in this case, the trapezoid is this piece right here. So this is the only thing that we're looking at. Okay, So when I trace those sides, do I know how long those edges are? I know this piece is 15. Do I know how long this diagonal is? No. Do I care on a trapezoid how long that diagonal is? No. As long as I know what the height is, okay? And the height of our trapezoid is going to go from one of these corners at a right angle down to the base. Okay, that's the height of our trapezoid. Okay, what about this line right here? Do I know how long this line is? It doesn't have a number here, but do you see that same line somewhere else in the picture? Do you see how it's the same as this 23 up here at the top? So if this across the top is the 23, then this piece right here is 23 as well. And again, I don't care about that diagonal. Okay, so on this trapezoid, this is going to be base 1. This is base 2, or two parallel lines are the bases, and then this height is the last thing that we need. So I don't have a number there. Okay, so I'm going to look at my picture. Do you see that same line, that same piece, somewhere else in this picture? Okay, and what I mean is, if you were to take that same line and like draw it over here, or draw it out here, or draw it over here, would you know that length? Okay, well, sort of. We know this thing that I colored in right here, from here to here, that's the H, right? But from this all the way up to the top of our picture is going to be 18. Okay, so all of this is 18. We need to know how much this is. So I guess the question is, do we already know how much this piece up here is? Do you see that this piece right here, this is the hardest part, y'all. Do you see how this piece right here matches this right here? That doesn't have a number on it. Can I take that same piece and slide it over somewhere else where it has a number? Look at that right there. See, that's 12. So if this side, left side of our rectangle is 12, this right side of our triangle is 12. And if the whole thing from top to bottom of our picture is 18, how much is that going to leave for this little piece right here? 18 minus 12 leaves us with 6. So the height of our trapezoid now is 6 centimeters. Okay, so I'm going to take these three numbers, 23, 15, and 6, and I'm going to bring them over here into my trapezoid formula. I'll zoom in just a little bit for this. Okay, again, if I start going too fast and you're like, whoa, I didn't get that written down, just pause it. It is okay. Pause and come back. All right, 1/2, we're going to change that to 0.5. Base 1 we said was 15. Base 2 is 23. And the height is 6. So I'm going to go to my calculator. 0.5 times 15 plus 23 times 6. Again, make sure that 15 plus 23 is in the parentheses. And that's all going to make 114. 114 centimeters squared. Okay, 114 and 276. So the rectangle up here on the top is 276 centimeters squared. The trapezoid down here on the bottom is 114 centimeters squared. So what should I do with those two answers? We're going to add them together. 276 plus 114 makes 390 centimeters squared for our total area. Cool? Okay, so again, we're going to break up our shape into smaller pieces. We don't want to make too many tiny pieces because then we're going to be doing way extra work. Okay, so the fewest number of shapes that you can have to make your composite figure, find the area of each of them, and then add them together. Okay, so the next one is this really cool picture. Okay, trust me, it took me a while to draw this, so you might want to pause and get that drawn. Okay, so we have this shape kind of here through the middle. What shape is that? That is a parallelogram through the middle. And then we have these two ends. How much is this? This is half of a circle. And this is half of a circle as well. And notice that if I shoved those two halves together, they would together make a whole circle. Okay, so I'm just going to combine those together to make one whole circle. Okay, so I'm going to have this parallelogram in the middle, area of the parallelogram, and then I'm going to have the area of the circle, and then we'll add them together and be done. Okay. All right, so area of a parallelogram is base times height. Area of a circle is pi r squared. Okay, so take a second, pause the video if you'd like, see if you can find the base and the height of this parallelogram. If this was all by itself and you didn't see any of this other stuff, okay, you might want to turn it, right? Let's turn it this way. If I turned it like this, hold on, and I got rid of all of this other stuff, and I just had this, how would I find the area of that parallelogram? How big is the base? Okay, the base is all the way across this line right here. I'll color it in highlighter. This is the base. Okay, I don't have any numbers along there, so I'm going to go up here to the top of my parallelogram. Those are the same, right? Those are congruent. I got a 6 over here on the side. How long is this whole piece going to be then? 6 and 6 makes 12. So this whole base is 12 inches. And what is the height? Again, look for the right angle to find the height. How far between these two parallel lines? This line right here, 5. Not the diagonals, 5. So I got a 12 for a base and 5 for the height. So 12 times 5 makes 60 inches squared. So that's the area of that parallelogram. And then we're going to do the area of the circle, pi r squared. Pi stays the same. R stands for radius, which is halfway across the circle. Okay, we've done two things. We've got all the way across the circle here, which we already know is 12. So halfway is going to be 6, which you could get from right here as well. This is the radius of our circle, 6 squared. So on my calculator, pi times 6 squared makes 113.1-ish, 0.097, if you want to be a little bit more specific. Okay, so those are my two areas. So all of this together, if I color in this whole shape, all of this together is 60 plus 113.1. So that's going to make a total area of 173.1 inches squared. Okay, area of each little piece, then we just add them together. Okay, all right. I know these seem a little complicated because this is probably something that you're not familiar with and you haven't done before. Imagine that, learning something new. What a concept. Okay, but again, this is more real life. We don't just have triangles and rectangles. We have combinations of those to make interesting kind of bubbly shapes and weird things. Okay, so let's see. What shapes do you see here? Yeah, you see this here? This is a rectangle. So we got a rectangle over here. This little thing right here is a triangle. And then down here we have half of a circle. Now notice on this one that we don't have another half to combine with it. So we're just going to find the area of half of that circle. Okay, so let's start with the one that has numbers on it. Okay, notice that this circle, half circle, or semicircle doesn't have any numbers. This triangle doesn't have any numbers with it. So let's start with the rectangle. Okay, I'm going to cover this stuff up. All right, we are looking for the dimensions of this rectangle. Okay, so I noticed that there's a 9 up there at the top. So if there's a 9 at the top, I can put a 9 down here at the bottom as well. Opposite sides of a rectangle are the same. Okay, is this 7 from here to here the same as all of this? They know. No, those are, thank you. Those are not the same. Okay, this line that I have drawn here on the right of this rectangle, is it the same as this 26 that goes all the way down to here? No, it would stop right here. So it's part of this 26. It's going to be less than 26. So what are we going to chop off down here at the bottom? Okay, what part of the semicircle is this line right here? Yeah, that's the radius of that semicircle. So what is the radius of this semicircle? Do you already see it there? It's the same as this, right? From the center to the edge, this is going to be 9. Same there? Cool. That's 9. So over here, this little piece on the outside is going to be the same as that 9 in there. So if this is 9 and the whole thing is 26, 26 take away 9 is, what's that, 17? So this top piece is going to be 17. Front edge there. Awesome. Okay, so let's start with area of the rectangle. Area of the rectangle is base times height, which we just said was 9 times 17. Okay, imagine that you're tracing along the outside of that rectangle, right? 9 times 17. 9 times 17 is 153. I'll come back to my labels when I'm all done. Okay, what shape do you want to do next? Which one? The triangle? Okay, area of the triangle is half base times height. Okay, so again, when I cover up all this stuff, notice I don't have any numbers on that triangle yet. Okay, can I figure out this line down here at the bottom? Is that the same as this 9 over here? Yep, because this is a semicircle, so this is going to be another radius of this circle. All three of these little lines are going to be exactly the same. Okay, so that's going to be one side of our triangle. The other side that we need is this piece. I'm going to use a highlighter for this. It's getting a little messy. I'm going to come right down here. I need that value. We said this one down here was 9, and if we can figure out this piece going vertically here, we will be good to go. Okay, so what I'm going to do is I'm going to come over here. I'm just going to slide this piece right over to here. Do you see how it would go from here to here? So it's part of that 17. Please don't say it's half. We don't know that it's half. Okay, do we know something about this piece up here at the top? Like this part right here that we're chopping off from that 17. Do you all know how long that line is? Do you see it somewhere else? Got to be parallel, going the same direction. Not out here, because that 17 goes all the way. What about over here? Do you see that? See that 7 right there? This little piece at the top is 7, and the whole thing from top to bottom is 17. So 17 take away 7. If I chop the 7 off the top, that's going to leave us with 10 down here at the bottom. Do you see now that 10 plus 7 makes 17? That's a 7 right there. Okay, cool. So now I'm going to use these two numbers, the 9 and the 10, find the area of our triangle. So we're going to do half 0.5 times 9 times 10. Half of 9 times 10. 9 times 10 is 90. Half of that is 45. Okay. And then the last one is the area of half the circle. So whole circle is pi r squared. So we're just going to cut that in half. We'll just do half of that. So 0.5 pi, what did we say the radius of our circle was? We already know the radius is 9. So half pi 9 squared. Half pi times 9 squared makes 127.2-ish. And what am I going to do with these three values now to find the area of all of this shape? We're going to add each one of them together. So 153 plus 45 plus 127.2 gives us a total area of 325.2. I'm going to go back and put a label on it. What were we talking about here? We were talking about feet, right? Area is always square feet. Okay, cool. All right, let's try one more just to make sure we're kind of all on the right track. Okay, this one's kind of interesting. All right, so on this one, we got 3 shapes here. We are going to divide them up. Let's see. So what do we have here in the middle, what shape is this? Yeah, that's a square. And then we've got this thing over here, which is a triangle. And then we've got this thing down at the bottom, which is a trapezoid. So we're going to do each of those and then add them all together. Okay? All right, so let's start with this number. Is this the side of our square? No. This is the height of the square, or the side of a square, plus the height of our trapezoid, which we don't really know yet. Does it look like this cuts it in half? No. So we don't really know how much is cut off here. So instead of starting over here, let's start over here with our triangle and see if we can kind of work our way this direction. Okay? All right, so on this triangle, I'm going to turn this sideways for a second. Okay, see my little triangle right there? All right, so on this triangle, we have a 9.6 coming from the top down to the base. So this is going to be the height of our triangle. And then we have this outside diagonal line, which is a 12. Is that the base? No. Okay, where is the base of this triangle? It has to make a right angle to the height. It's going to be all the way across here. All of this is the base. So we're going to need to solve for that. And in order to do that, we can use this side of our triangle, and we're going to do Pythagorean theorem real quick. Okay, hopefully y'all have been keeping up with your Pythagorean theorem. We're going to square our two numbers, this 12 and the 9.6. If I square both of those, then I just need to decide, am I going to add these together because I want this side that I'm trying to find to be bigger, or do I want to subtract because I want it to be smaller? Absolutely, this is going to be smaller. Okay, so what we're finding is we're finding this piece right here, from here to here. Is that going to be the base of our triangle? No. What am I going to have to do to this number to find the entire base? We're going to double it. We're going to multiply it by 2 because it's going to be the same thing over there. All right, so square root of 12 squared minus 9.6 squared makes 7.2. So this piece right here is 7.2, and this piece over here is 7.2. So together that makes 14.4 for the base of our triangle. And which one did we say we're going to use for the height? The 9.6. Okay. All right. So over here we've got area of a triangle, half base height, 0.5 times 9.6 times 14.4. And if you want to do like little parentheses or something, because that's too many dots that look like decimals and stuff, that's cool too. 0.5 times 9.6 times 14.4 makes 69.12. We'll just leave it like that. Okay. Okay, let's do the square. Square is the same as a rectangle, base times height. Do we know how long one side of our square is now? This is one side of our square, right? 14.4. How long is this side of our square going to be? 14.4. How long is this side going to be over here? 14.4, 14.4, right? So I'm just going to multiply those together. 14.4 times 14.4. Or 14.4 squared, which is 207.36. Right? That was easy. Now we just got that little trapezoid down there at the bottom. All right, what did we say the area of a trapezoid was? 1/2 base 1 plus base 2 times the height. All right, on our trapezoid, remember the bases are the two parallel lines. So what are those two numbers? 10 and 14.4. So I'm going to put those in for base 1 and base 2. And then we need the height. Okay, the height is going to go like this. right there, that's going to be our height. There is no number there. Anywhere along our trapezoid, no number. Okay, can I bring it out here? That's the height. All of this from top to bottom is 25.4. So how much is the square going to remove from that? 14.4. So if the whole thing is 25.4 and we're removing 14.4, that's going to leave us with a height of 11. Height is 11. 11. Cool. Calculator. 0.5 parenthesis 10 plus 14.4 close parentheses times 11. 134.2. Okay. So the three individual shapes have areas of this. What am I going to do with those three numbers now? Add them together, right? This plus this plus this. Sorry, that's hard to see with highlighting now. So we're going to take 69.12 plus 207.36 plus 134.2. And we get a total area of 410.68 meters squared. Oh, sorry. 410.68. Okay, this can be a little tricky. Again, make sure you're dividing it up into smaller sections where you can find the area of each one of those. Make sure you're using your formula. Excuse me. And then type in your calculator. Okay? Again, if you have questions, you all know how to find me. Okay? Please ask questions. Okay? It's a really weird time, so if you're sitting at home struggling, I'm sitting at home bored. I would love to help. Okay? Well, not totally bored, but, you know. I'm a teacher. I live to help. So, please ask. Okay? All right. Love you. Bye.